pediatric doses. Often our medication inserts will have a pediatric dose available to us for drugs that are commonly used in children. Now we can't do research on children because that's unethical, but this data comes from a historical review of medications used and their outcomes and adverse events. But what do we do when we don't have any information on children dosing and I have a medication that's being prescribed to a child? Well, we're going to show you some formulas today that you can use that take into consideration the patient's age, their weight, and body surface area so you can make sure you're giving the right dose to your child. And we're going to do all of that right after this. Welcome back. My name is Tammy and this is Nurse Minder, and on this channel we do everything nursing. So if you're new here, consider subscribing below so that you get the next video when it's released. So one of the reasons that we have to calculate a different dose for children is because they work with medications differently. Remember how pharmacokinetics, we talked about this in a previous video, how the body absorbs medications, how it breaks it down, metabolizes it, distributes it, and excretes it. Well, the child's body is different. The organs sometimes are a little bit less capable of functioning to the way that the adult does. So we need to create a dose that's safe for them but still gets us the therapeutic outcomes we're looking for. We're going to start with age first. It's probably the easiest calculation to do, and we don't require any tables or diagrams. So we're simply just going to take the data we have to make sure we have the right dose. We have Fry's rule first, and this is for our children less than 1 year. I should write that in here. Less than a year old. So maybe you can think of a fresh infant to help you remember that Fry's rule applies to months. So a child dose is equal to the age in months. Divide that by 150, and we get this number because we assume that the adult dose is based on someone who's 12 and a half years, which is equal to 150 months. So that's an assumption we need to know off the top. So again, for Fry's rule, less than a year, a child dose is age in months, divide by 150, that's our number of months for a adult dose, and then we multiply that by the average adult dose. So for example, if I want to give Tylenol to my infant, they've got a fever, and they're 6 months old, and I don't have any information on the package insert, I can do a quick calculation. 6 months divided by 150 months times by 650 milligrams. When I calculate this all out, my months will cross off. I'm left with milligrams. It means I'm going to give 26 milligrams of Tylenol to a 6-month-old infant. If we're working with somebody who is over that 1 year mark, we're actually going to use their age in years. And this is where Young's rule comes in. You can think of this as years. Young youth, 1 to 12. Fry's was for infants. And we're going to use months there. So in Young's rule, we're going to use their age in years. We divide that by their current age plus 12, and then multiply that by the average dose of that medication for an adult. So if I've got a 4-year-old and I still want to give Tylenol, they're 4 years old, I divide that by 4 years plus 12. My years will cross out. So now I've got 4 divided by 16. Multiply by 650, and it gives me 162.5 milligrams. A really quick check to make sure that your medication that's ordered is the safe dose for your child or infant. Now it's your turn. You've got a 3-month-old infant, and the average adult dose of this medication is 400 milligrams. What is your dose? Similarly, finish calculating out if you had an 8-year-old child and the average dose was 400 for an adult, what would be the dose you give that child? So go ahead and pause this video, complete your calculations, and then press play when you're ready. Alright, so what I'm hoping you found out is 8 milligrams would be your infant dose based on the age and the average adult dose for this medication. And if you were giving that same medication to a youth of 8 years old, that your dose would be 160 milligrams. Let's move on to weight. So we can also use the patient's weight to make sure we have the correct dose for our patient. In Clark's rule, we're making the assumption that the average male adult is 150 pounds, and most pharmacological studies were done on males, and so that's why we use the average male weight. Okay, so this is the same number that we used for children's age. We used 150 months, so this time we're going to look at pounds though. So we have the child dose is equal to the child's weight in pounds divide by 150 pounds times by your average adult dose. So go ahead and figure out if you have a child that weighs 54 pounds and the average dose is 650 milligrams, what will be your dose? Pause this video and return when you're done. Okay, so that should be relatively straightforward. We have 54 pounds, divide by 150 pounds times by the dose of 650 milligrams. After my pounds cross off, I'm left with milligrams, and my dose is 234 milligrams for my child that weighs 54 pounds of a medication whose regular adult dose is 650 milligrams. Next, we're going to look at body surface area. So using a nomogram, we're going to be taking our patient's height in either centimeters or in inches, and we're going to be lining that up with their weight in either pounds or kilograms. Let's just say I have a patient who is 100 centimeters tall and they weigh 50 pounds. I'm going to take my ruler here and I'm going to line up my 100 centimeter tall to my 50 pound patient. This now will then intersect with my surface area, and it's going to give me a value, and it looks like it's 0.82. So if I look at that line, I'm just going to move my measurement away. There's 0.8 and there's 0.9, which means each little line is worth 0.02. So 0.8, 0.82, 0.84, 0.86, 0.88, 0.9. And I was at that first line. So 0.82 meters squared. Okay, so based on my nomogram with someone who is 100 centimeters tall and is 50 pounds, I came up with a surface area of 0.82 meters squared. So the next thing is to plunk this into my formula. The formula for body surface area calculations is very similar to the formulas we've been doing in the past. The difference is we're taking our surface area, so 0.82 divided by 1.73, and then timesing that by the average adult dose. So with that, go ahead and figure out what my dose will be based on my surface area. Awesome, so what you should have is 308 milligrams. So I left this 308.09 in here because I want to talk about the rounding rules. When it comes to decimals, the rounding rules say that if it is less than 0.5, we're going to round down. If it's greater than or equal to 0.5, then we're going to round up. So because I have 308.09, that's less than 0.5, it will be 308. If it was 308.52, we would go up to 309. So just to remember that the rounding rules do come into play here when determining your calculation. So we have covered 4 different ways to make sure that your child's dose is calculated correctly. We've gone over Fry's rule. Remember, those less than a year are done in months. Young's rule, 1 to 12 years. Clark's rule is weight-based, and then the nomogram is body surface area. So we have a variety of tools we can use to make sure our patients get safe care. You know, our medication rates involve us knowing as nurses that the right dose is being given. So always check your doses for accuracy. And until next time, make it a great day.